In this section we will talk about uniform circular motion. In a carnival you would see rides that moves in a circular motion like this carousel. Although these rides move at a constant velocity, it experiences an acceleration. Objects moving in a straight line at constant velocity produces zero acceleration. However, for objects moving at constant velocity in a circular path produces non-zero acceleration, which we have learned earlier in kinematics. Now we will study the forces that are involved in objects moving in curved or circular path. Here we have block of mass moving in a circular path. We see that its velocity is perpendicular to its path at all points while its acceleration is directed towards the center. When the block of mass is suddenly unconstrained from its path, it will be shot out and its direction will be straight and the same as that of the velocity that was tangential to the circular path. This can be demonstrated when you tie an object on a string and begin by rotating and suddenly letting it go, and you will see that the object will move in a straight path. The distance traveled by the block of mass over certain time is simply the change in its arc length, and we know this to be S equals R times delta theta. Rewriting this to get an expression for theta and substituting the value of the total length of a circular path, we get 2 pi radians. So, for a one-hole rotation or revolution, the block of mass moved a distance of 2 pi radians. Angular velocity is the circular velocity of the block of mass as it moves around the path. Its symbol is omega. Although it looks like a W, its equation is simply the rate of change of the position theta over the change in time as it moves from point A to point B. Its angular velocity is similar to that of the tangential velocity in the sense that it represents as the speed of the block. As what we have done earlier where we related the distances in terms of arc length and theta, we will also do the same for the angular velocity and tangential velocity. This can be expressed as the angular velocity is equal to the tangential velocity divided by the change in time, or simply time. Centripetal acceleration or radial acceleration is the acceleration that is directed towards the center of the circular path, and it is sometimes denoted as AC. If we examine the 2 points in the circular path where the block of mass is traversing, we see that the vector sum of the velocity vectors in points A and B would result to the change in velocity as shown in the figure. We see that the direction of the change of the velocity is directed towards the center of the path. The direction of the change in velocity is also the direction of its acceleration, or for this case it would be direction of the radial acceleration. We then compare the triangles formed by O, A, and B with the triangle formed by O', A', and B'. Note that the VA and VB are the same, so we can simply denote them as V. Both triangles are isosceles triangles having equal sides, so we can relate them as having equal proportions. For the first triangle, the change in radius and the change in arc length are similar, so we can approximate them as the same. So we have the ratio of the change in arc length over the radius equal to that of the change velocity over the tangential velocity. Calculating the magnitude of radial acceleration, it's simply the ratio of the square of the tangential velocity or linear velocity over the radius of the circular path. The acceleration can also be expressed in terms of the angular velocity. To calculate for the force, or for this case radial force, we simply multiply this by the mass of the block and get that the force is equal to the mass times the square of the velocity divided by its radius. It can also be expressed in terms of its angular velocity, which is equal to the mass times the radius times the square of its angular velocity. Thank you, and I hope you learned something new today. For questions and comments you may send them to diyeslearningstuff@gmail.com. You may review the slide on YouTube at Dies Learning Stuff. Note, Please do not forget to use your school email, your name, and class section. Thank you for listening and see next module.